Today, we're going to pull back the curtain on the hidden math that powers pretty much your entire digital life. It's the invisible blueprint behind everything from your phone to the latest video games, and we're going to see exactly how it all works.
I mean, really think about it for a second. You turn your phone, and bam, instantly millions of tiny pixels just rearrange themselves into a perfect new layout. Now that's not magic, it's math, and it's the perfect place to start our journey.
And that secret ingredient, the thing that makes it all happen? It's called the matrix. Yep, that's it. It's the invisible framework that organizes all the data and graphics that we tap and swipe through every single day.
So, at its heart, a matrix is really just a simple grid of numbers, right? Rows and columns. But you can't let that simple look fool you. This structure is one of the most powerful ways to organize and play with huge amounts of information. Think of it like the ultimate spreadsheet, but built for really, really complex tasks. Okay, so let's grab our first tool from the toolbox. This is the heavy lifter, matrix multiplication. This is how we take different sets of data and combine them to create something totally new, like, say, rotating a 3D model in a game or running a massive financial simulation. But before you start using this power tool, there is one critical rule. It's the golden rule, really. To multiply two matrices, the number of columns in the first one has to equal the number of rows in the second one. If they don't match up, the whole thing just doesn't work. It's the fundamental law of the land here.
The process itself kind of follows this simple, repeatable rhythm. You take a row from the first matrix and you pair it with a column from the second one. Then you multiply their matching elements and just add up the results. That final number, that becomes a single entry in your brand new matrix. You just keep doing that little dance until every single spot is filled. Let's actually see it in action. Okay, check this out. The color coding here breaks it down perfectly. See how the first row of the first matrix, the red one, is paired up with the first column of the second matrix, the blue one. We multiply the matching numbers, 1 times 5 and 2 times 7, and then we add those results up to get 19. And there it is. That's the very first number in our new matrix. It's a perfect picture of that row times column dance.
All right, let's move on to our next tool. This one is way simpler, but it's just as useful. It's the matrix transpose. So if multiplication is our power saw, think of the transpose as your trusty wrench. It's perfect for a quick little adjustment to get a totally new angle on your data.
The whole idea here is super direct and really powerful. You just flip the matrix. That's it. The first row becomes the first column. The second row becomes the second column, and you just keep going. It's a fundamental way to quickly restructure your data when you need to look at it differently.
Here's a perfect visual. The original matrix on the left, you can see it has 2 rows and 3 columns. Now watch what happens when we transpose it. That first row with a circle, triangle, and square, it just pivots and becomes the first column on the right. We started with a 2x3 matrix, and we ended up with a 3x2. It's a simple flip, but it's an incredibly powerful way to reorganize things.
So we've got our two main tools, multiplication for combining and transforming data, and transpose for just flipping it around. Now let's see how this, abstract math stuff actually builds the digital world we were talking about right at the beginning.
And the applications are literally everywhere. That screen rotation we started with, that's a whole series of matrix multiplications. Animating characters in video games, that's just more matrix multiplication. Scaling them, rotating them, moving them through 3D space. But it goes so much deeper. These exact same operations are absolutely crucial for training AI, for encrypting our secure data, and even for describing the state of particles in quantum computing. Wild, right?
So, let's do a quick recap of the 2 essential tools we've just added to your mental toolbox today.
It really all boils down to this. You've got multiplication, your tool for transforming and combining data, and its core idea is just row times column. Then you've got the transpose, your tool for reorganizing and flipping data, where the rule is simply rows become columns. 2 simple ideas with truly endless applications.
So, the next time you pinch to zoom on a map, or you watch some incredible special effects in a movie, or even see a complex financial forecast, you can remember the simple logic that's humming away behind the scenes. You now have the tools to see it. So the real question is, where else in your digital life do you think these matrices are hiding in plain sight?